Hello everyone, very good evening. Kindly confirm if audio video is clear. Okay, all set. All clear. Okay, thank you very much. Let's begin with the sixth lecture of this series of database management system and the second lecture of structured query language. In the last session, we have already defined the different commands of SQL, whether it is create command, drop command, alter command, truncate command, insert command, delete command, update command, and select command. So we have seen all those commands. We have defined different aggregate functions like count function, sum, average, min, max. We have seen the example of each and every one of them. We have seen different SQL clauses. We have also defined the order of execution. Now, what are we going to cover in the today's session? So, sir, another important concept in the structured query language is the concept of subquery. So, we need to see that what are the different types of subqueries, what will be the order of execution for the different types of subqueries, what are the different operators that can be used with those different types of subqueries. So, broadly, there are two different types of subquery. One is independent subquery, another is a correlated subquery. The operators used along with this different subqueries will be in operator, any operator, all operator, and exist. So these are the operators which are generally used with this different types of subquery. So let us discuss that what do I mean and when exactly do I need the concept of subquery. So if I ask you, let's assume that this is your relation student. Let's assume this is your relation student and these are the tuples in this relation student. If I ask you to retrieve the SIDs of the students with maximum marks, what will you do? If I ask you to retrieve the SIDs of the students with maximum marks, then what should be the query for the corresponding situation? Anyone? So, sir, we need SID, so you can say select. You can skip distinct because all the SIDs are distinct, so you can say select SID from table student where, okay. So, if any one of you thinking to write where marks are equal to the max of marks, will it be correct? That's the very first question that you should be asking yourself. So, as I said, that structured query language is a non-procedural query language. There are some valid syntax, there are some invalid syntax. So, this is an invalid syntax. This is an invalid syntax. Why? This is an invalid syntax. The reason is that you cannot use aggregate function directly within the where clause. You cannot use aggregate function directly within the maximum within the where clause. So please, why we cannot use aggregate functions directly within the where condition. Okay. So if I need the students with maximum marks, then what should we do? So this will be an invalid query, but what will be the correct query? So this is wrong. So it is also very important to understand that what is right and what is wrong from the structured query language point of view. Because otherwise, if there is an MSQ, then you will be confused that whether both of them are correct or only one of them is correct and others are false, right? So what will be the right query? So you will have to select SID from student where marks is equals to maximum of marks of the table, but you cannot write it directly. So in place of this, you will write where marks equals to, you will write another query, that is select max of marks from select max of marks from a student, and this will be the correct query. So what will happen in this situation? So this is called subquery. This is your subquery or nested query, and this is your main query, right? So what will happen because of this? Sir, first of all, we will eventually get the maximum marks from the student table, and those maximum marks will be compared with the marks of each tuple. Please, where condition will be applied on each tuple. Where condition will be applied on each tuple. So even if we use this particular situation, please try to understand. Anyway, this is invalid. Anyway, this is invalid. But even if it is valid, then what will happen? Even if it is valid, then what will happen? Even if it is valid, then where condition will be applied on each tuple? Where condition will be applied on each tuple. So when you calculate the maximum marks for a tuple, then the maximum marks will be the marks of that particular tuple itself. Yes or no? Got the idea? This is an invalid syntax from the structured query language point of view. But my question is, let's assume that it is a valid syntax. Even if it is a valid syntax, then also, because where condition is applied on each tuple, then this maximum of marks will be calculated for each tuple, and for a particular tuple, maximum marks will be the marks of the tuple itself. Marks of that particular tuple will also be the maximum marks corresponding to that tuple. Therefore, this condition will be true for all the tuples. Therefore, this condition will be true for all the tuples even if this syntax is valid. Getting the idea? So, therefore, we do not use the aggregate function directly within the where clause. Whereas, if you want the output of an aggregate function, then it will be written in the form of a subquery. It will be written in the form of subquery. So this is an independent subquery. Please try to understand. Forget about everything else. Forget about everything else. Can we execute this query independently? Can we execute this query independently? Sir, if nothing else is available, then also this query can be executed. Make sense? So this is called an independent subquery. So there are two different types of subquery. One is independent subquery, another will be correlated subquery. So the very first concept is to understand that what exactly a subquery is. The very first thing that you need to understand is what exactly a subquery is. Now, if you understand that what exactly a subquery is, then let me define the different types of subqueries. Different types of subqueries. Okay, so yes. There are two types of subqueries. One is independent subquery or uncorrelated subquery. Both are the same thing. Another is correlated subquery. So what is independent subquery? Sir, another aspect of this is, so this is also known as inner query. This is known as inner query. And this is known as outer query. So when inner query can be executed independently of outer query, then it is called independent nested query. So when do we say independent subquery? When inner query, please, inner query is independent of outer query. Okay, what is correlated query? Sir, a query in which this is important, most important, sir, very, very, very important from the gate point of view. This is a very important concept from the gate point of view. So can I try to understand this with complete detail. So when do we say correlated query? When inner query requires the value of an attribute defined in outer relation when inner query requires the value of an attribute defined in outer relation for its execution, then it is called correlated query. Not clear, sir. So let me first give you the example of independent query, then we will move to the concept of correlated query, which is most important. So let's say if I say select, let me use the same thing, select SID from a student where marks equals to select max of marks from a student. Anyway, so we can execute it independently, therefore it is independent query. Okay, one more important concept related to independent subquery is that independent subquery or inner subquery will be executed only once. Inner subquery will be executed only once, and the output of that subquery, output of the execution of that inner subquery will be used for every tuple of the outer query. Output of that inner subquery will be used for every tuple for the outer query. Clear? So inner query will be executed only once, and the order of execution will be that inner query will be executed first. If inner query is independent query, then it will be executed first. Yes. If inner query is independent query, then it will be executed first. It will be executed first, and the output of that subquery will be used for the execution of outer query. And come on. So if we look at the tables, if we look at the entries available in the student relation, then we know the maximum value with respect to marks is 60. So this inner query will be executed first. It will produce the result 60. It will produce the result 60, and the tuples of the student relation will be compared one by one such that the marks are equals to 60, and based on that the output that you will receive is, sir, only two tuple will satisfy the condition in which marks are equals to 60, and those will be with respect to S3 and S4. Those will be with respect to S3 and S4. Therefore, the output of this query will be S3 and S4. Clear? Clear? It's the simplest form of subquery where inner query can be executed independently. If it is the case, then that particular query will be executed first, and whatever the output of that particular query is or subquery is, that will be used for the execution of outer subquery. Simple. No complex stuff associated with independent subquery. But what happens if the query is correlated subquery? How do we identify that the query is a correlated subquery? So let me explain the example. If I write something like that, select whatever you want to select. Let's select everything, no problem. Select as everything from, let's assume that the outer relation is R. Relation in outer query. So select this from where. After where you will write something, right? So let's say this where starts. Let's say this where starts, and then you have something else. Select, let's say everything. Select everything from some relation S. Come on. So now the very first thing that you need to understand is, sir, is it necessary for inner relation to be different from outer relation? No, sir. Inner relation may be same as outer relation, but the names for the alias will be different. Yes or no? So this is the alias with respect to inner query. So it may be same. Relation may be same as outer relation. But different alias will be used. So rename. The same relation can be renamed with a different name. Same relation can be renamed with a different name. Then you have from S where. Come on, look at this. This is the important thing. Sir, I am writing a where condition in which we are trying to compare some attribute A. We are trying to compare. It may be any comparison operation. This need not be equal. Any comparison operation. But the basic understanding is that, sir, this is your inner query. This inner query for the execution uses the attribute from the inner relation as well as an attribute from the outer relation. So it is saying where S dot A is equals to the attribute B of relation R. Come on, sir. What just happened? What just happened? Please try to understand. Now, this is your outer query. This is your inner query. Now my question is, can you execute the inner query without taking help of outer query? Can you execute inner query independently? Look at this inner query. Can you execute inner query independently? No, sir. This inner query requires an attribute B from the outer relation. This inner query requires an attribute B from the outer relation. Therefore, until the value of attribute B is available, I cannot execute this inner query. Yes or no? So, attribute from outer relation. This inner query cannot be executed independently. Cannot be executed independently, therefore, correlated query. So, whenever you are trying to check that what output will be produced by a given query, the very first thing that you will have to check is whether the inner query is an independent query or correlated query. Outer, inner, outer. For every tuple of outer query, we will execute inner query, right? So order of execution we will understand. We'll understand order of execution, but yeah. So this is how an correlated query will look like. So what did we say? If inner query is an independent query, if inner query is an independent query, that inner query will be executed first, and based on the output of the inner query, outer query will execute. But here, how do we define the order in which the inner query will execute? So let me define it. So correlated query. What are we discussing? The correlated query, and we are discussing order of execution. And this is the most important thing with respect to correlated query. You must understand that in what order the inner query, or in what order a correlated subquery will execute. So what will happen? Sir, please try to understand. There are some basic things that you need to understand, and if you understand that, it will be okay for, you will understand the complete concept. So what happens? Sir, in the outer query, we only have three different things: from, select, and where. In outer query, we have only three different things: from, where, and select. How exactly a query with from, where, and select will execute? Sir, you will take the first tuple from the outer relation R. Yes or no? How exactly? So whatever is selected in the final output will be from relation R. I hope it is clear that the final output will be produced from relation R. Final output will be produced from relation R. So how exactly a query with three different things, that is select, from, and where, executes? That's what you need to understand. So we will take one relation we will take one tuple, forget about this green color query, forget about it, no longer visible to you. You will take one first tuple from relation R, and for that first tuple, you will check whether the where condition is true or false. If where condition is true, for the first tuple, then that first tuple will be selected and the output from the first tuple will be produced. Similarly, if for the first tuple where condition is false, for the first tuple, if where condition is false, then that particular tuple from the relation R will not be selected and no output will be produced with respect to that tuple. So simple concept is you just need to check whether for first tuple this where condition is true or false, for the second tuple where condition is true or false, for the third tuple where condition is true or false, yes or no. Forget about this inner query. Forget about this inner query. You only need to check whether this where condition is true for first tuple or false, whether this where condition is true for second condition or false, and so on. Make sense? Simple concept. Simple concept. So what will you do? Sir, you will take the first tuple from relation R. You will take the first tuple from relation R, but the output of where clause will not be available until this inner query executes. Yes or no? Because the output of where clause, whether it will return true or false, will depend on the output of inner query. Make sense? Sir, where within the where you have this inner query. Within this where clause, you have this inner query. This inner query is within the where clause. So the output of where clause, whether it is true or false, will depend on the output of this inner query. Yes, sir. So we cannot simply check whether the where clause will return true or false. So what we need to do? Sir, for the first tuple of relation R, we will have to check that what output will be produced by the inner query. And to check that what output will be produced by the inner query, what will you do? Sir, the second thing, so please try to understand the order. You will take the first tuple from relation R. You will take the first tuple from relation R. With that tuple, you will go to the inner relation. With the first tuple of relation R, you will go to the inner relation and then you will compare whether this where condition is true or false. Now the idea is, with respect to first tuple, first of all, you will take first tuple of relation S. Let me explain. So, first you will take first tuple from relation S, then you will check the where condition, whether it is true or false, then you will check whether it should be selected or not. Then you will check the second tuple from relation S, then you will compare the where condition, then you will decide whether it should be selected or not. Then you will take the third tuple from relation S, you will compare the where, you will check the where condition, then you will decide whether the third tuple should be selected or not. So the idea is that with respect to each tuple of outer relation, complete inner query will be inner query will be executed on complete inner relation. Getting the idea? You will take first tuple from relation R, you will take first tuple of relation from relation S, then you will compare this where condition, whether this where condition with respect to inner query is true or false, then you will decide whether this tuple from the inner relation should be selected or not. So this steps 2, 3 and 4 will be executed repeatedly on complete relation S with respect to each tuple of relation R. Yes or no? So what will happen? So 2, 3 and 4 will be executed repeatedly on complete relation S with respect to each tuple of outer relation R. With respect to each tuple of outer relation R. So we'll take the first tuple. With respect to first tuple, you will execute this inner query on the complete inner relation S. Now, when you have executed this inner query on the complete inner relation S, then based on the output of this inner query with respect to first tuple, based on the output of this inner query with respect to first tuple, you will decide whether this where condition is true or false. So once you have executed these three conditions repetitively on the complete inner relation, you will decide whether where condition will return true or false. Make sense? Now, the where condition may be true, where condition may be false. If where condition is true, then corresponding tuple of relation R will be selected. If where condition is false, then corresponding tuple of relation R will not be selected. So finally, the decision will be taken whether the tuple from relation R should be selected or not. Make sense? The order of execution is clear. The order of execution is clear. I'll explain everything. I'll give you the example for this, but the intuition is clear that for each tuple of relation R, we need to execute this inner query on the complete inner relation. After executing the inner query on the complete inner relation, we will be able to decide whether where condition is true or false. Based on the output of where condition, we will decide whether the tuple from the outer relation should be selected or not. This is the order. If you understand this order of execution, then you know the concept of correlated subquery. If you know the concept of correlated subquery, 50% of the question that has been asked in the GATE exam, you will be able to solve them. Damn sure, you will be able to solve them if you have understood this particular order. Now another thing is, sir, why this? So there will be some operators. We'll use some operators. These operators will either return true or false. So if the operator returns true, where condition will be true. If operator return false, then where condition will be false. So what are these operators? What are these operators? Based on the output of this operator, we will decide whether the where condition is true or false. So there are 4 different types of operators. Forget about this. I have copied it from the previous slide. So let's look at the operators. So there are 2 types of queries, independent subquery and correlated subquery. So generally, I am not saying that there is any restriction that which operator will be used along with which type of subquery, but generally in any and all are 3 different types of operators which are used with independent subquery, whereas exist is the operator which is used with correlated subquery. Clear? So operators. So please note down best used operators with independent subquery are what? In any and all. So please don't find any restriction. May also be used with correlated query. May be used with subquery. But generally they are used with independent subquery. That's what I'm trying to say. Don't make any conclusion. Okay. And the best use operator with correlated subquery will be exist. So what exactly will be returned by this in any, all and exists? In any, all and exists will either return true or return false. So these are basically comparison operators. So in, any, all, and exists will return true or false. So as I said, some operators will be used along with where clause. So if you are using in at this particular place, and if in returns true, where condition will be true. If in returns false, where condition will be false. If you are using any, if any returns true, where condition will be true. If any returns false, where condition will be false, etc. Clear? So these are certain things. So those operators will be available in this correlated subquery at certain position, and based on the output produced by those operators, we will be able to decide whether where condition is it true or false. So let me explain this operators first, so that you will be able to understand the concept with more clarity. So in is actually an operator which is used to check whether the tuple is present in the set of tuples produced by inner query or not. So why do we use this? Sir, in operator is used to check whether a tuple whichever tuple you are checking for, whether a tuple is whether given tuple, whichever, whether the given tuple is present in the set of tuples produced by inner query or not. What the idea? Whether it is present in the set of tuples produced by the inner query or not. So I hope, as I told you, that this inner query will produce certain tuples. Now we'll check whether some value from this first tuple of relation R is in this set of tuples or not. Is in this set of tuples or not. If it is in the set of tuples, then in operator will return true. If it is not in the set of tuples produced by inner query, then inner query will produce, or then in operator will return false. Clear? So, sir, still not clear. So let me explain that the inner tuple can be anything. Tuple can be anything. So if I'm checking for whether X in this set of tuples. So let's assume that this is the output. Let produced by inner query. Okay. So let's assume 5 values are produced. 5 values are produced by this inner query 1, 2, 4, 5, 9. Right. Now, what happens, sir? If X is any one of this, what happens if X is equals to 4? Please tell me. So check whether 4 is in this set of tuples or not. Yes, sir. 4 is in this set of tuples. So 4 is in this set of tuples. Therefore, in will return true. Similarly, if I take some value, let's say if I take X equals to some value 7. So whether 7 is in this set of tuples or not? No, sir. 7 is not present in this set. Therefore, in will return false. Okay, let me explain some other thing. What? So we can also use the complementary operation with respect to in. So complement of in is not in. So at the place of in, you may use not in. So when in returns true, not in will return false. When in return false, not in will return true. So these are two different types of operation. Either you can use in or you can use not in, which will be the complement of in. Now another concept that you need to understand. Sir, what if this inner query result is empty? Sir, can any non-empty thing be present in an empty set? No, sir, it is never possible. So, if inner query result is empty, if inner query result is empty, if the result produced by inner query is an empty set, nothing is selected by the inner query, then in operator will always return false and not in will always return true. Make sense? So, please note down, if inner query result is empty, then in operator will always return false. Then in operator will always return false. So, okay, let me give you an example. Let me give you an example in which I am using in attribute. So, consider the following relation. Consider the following relations. If I say that there is a relation with the name supplier, there's a relation with the name parts, there's a relation with the name catalog. Now, supplier have SID, S name, and let's say address. Parts have PID and color. Only two attributes. What is the ID of the part and the color of that part? Catalog has SID, the part supplied by that supplier, and the cost at which the supplier has supplied that part. Let's assume the key is SID, key is PID, and the primary key of catalog and SID and PID together. If I ask you, so there are various ways of writing the same query. So say retrieve SIDs of the suppliers supplied some red color parts. It's damn easy. There are various ways of doing this, but let me explain it with the help of independent query. If I first select the PIDs of all the parts which are of red color, so let me do one thing, that if I select PID from parts where color equals to red. So this will give me the PIDs of all red color parts. This will give me the PIDs of all red color parts. Now, if the supplier, let's say assume in the catalog table, come on, let's say this is your catalog table, and if I say that the supplier S1 has supplied a part P1, S1 has supplied a part P2, S2 has supplied a part P2, S3 has supplied a part P3. Let's assume that this is your parts table, and let's say that there are three parts P1, P2, P3. Let's assume P1 is of red color, let's assume P2 is of green color, and let's assume P3 is also of red color. So my question is that what output will be produced by this inner query? So inner query will give me a set which will contain PID, P1 and P3, because these are the only two PIDs. These are the only two PIDs of red color parts. These are the only two PIDs of red color parts. Now in the outer query, if I write something like this, that select, so I will say select SID from catalog. So from the catalog, we will select SID where where clause will return true, where PID in this set of tuples produced by this. So please check. So we will take the first tuple S1P1. So S1P1, the PID of the first tuple P1 is in this set of tuple. Therefore, this will be selected. Got the idea? Sir, S1 will be present in the output. Come on, sir. Sir, as soon as supplied part P2, we will check whether P2 is in this set of red color PIDs or not. No, sir, no, sir, no, sir. So this S1 will not get selected. Sir, S2 P2. P2 is in this set of tuples or not? No, sir, it will not get selected. S3 has supplied P3. P3 is in the set of red color parts of not or not. Yes, sir. P3 is in this set. Therefore, S3 will also get selected. So you have selected the suppliers. No, 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 no. You don't need to use any. Come on, check. We are checking tuple by tuple. So if a specific PID is in the set of red color parts, that means the corresponding supplier has supplied at least one red part. If the PID is not in the set of red color part, then with respect to that tuple, the supplier should not get selected. That's the only thing. Distinct, you don't need to see. The idea is you can use distinct. Yeah, if you want, you can use distinct PIDs. So retrieve SIDs. So you can use distinct because a particular supplier may have supplied more than one part of red color. A particular supplier may have supplied multiple parts of red color. So in that specific case, multiple times or the duplicate tuples will be produced with respect to that particular supplier. But the question did not ask for retrieve distinct SIDs of the supplier, so both of them are correct. The question did not ask for distinct SIDs. Shri Harsha. And the question did, or the query did not ask for distinct SIDs. Therefore, if you use simple select SID, then also it will be considered correct. No problem with that. Come on, sir. So we are done with this. Let's move to the next concept, that is any operator. So please, there is an important thing. Any and all, both of them will be used along with other comparison operator. What's the idea? Any operator, any is an operator, will be used along with, it cannot go alone, along with other comparison operators. So what are the comparison operators? So it can be anything. You can have less than, you can have greater than, you can have less than equals to, you can have greater than equals to, you can have equals to, you can have not equals to. So this is the symbol for not equal. This is the symbol for not equal. You can use any operator along with, you can use any comparison operator along with any operator. Clear? So, sir, how does it actually work? So, any operator will return, any. So, it's somewhat like there exists at least once. All will be for all. I hope you understand the concept of discrete mathematics. In discrete mathematics, we learn there exists and for all. So, there exists means for at least one. If the condition is true, there exists will return true. Now, for all, if there is any one for which the condition is false, for all will return false. Yes or no? So, this is the similar type of situation. This any is same as there exist. At least one. So, when exactly any operator will return true? So, any will return true if and only if any will return true if and only if at least one tuple in the set of tuples. Set of tuples, when I say, then the output of inner query. So at least one tuple in the set of tuples satisfy the comparison condition. So at least one tuple in the set of tuples satisfy the comparison condition. So what does it mean? Let's take an example. So X in this set of tuples. So this is, let's say, assume output of inner query. For just for understanding. Output of inner query. Let's say if I write 2, 3, 5, 7, 8. 2, 3, 5, 7, 8. Okay. N ki baat, we are not talking about n. So let's assume that the operator used is less than or equals to any. So we are using any with less than or equals to. We can use it with any operator. We can use any along with any comparison operator, and this time we are using any with the comparison operator less than or equals to. So my question is, what will happen if x is equals to 6? So is 6 less than any one of this? Is 6 less than or equals to any one of these elements in the set of tuples? So please try to understand. First of all, we'll compare 6 with 2. No, condition is false. Then we'll compare 6 with 3. No, condition is false. Then we'll check 5. No, condition is false. So 6 is less than or equals to 7. So the moment we found one element for which the comparison condition is true, we will not check for remaining element. At least one. So the moment we found any tuple that satisfies the comparison condition, we will not check with remaining tuples. We will not check with remaining tuples. Will not be compared. Come on. So if x equals to 6, any will return true with respect to 7. Come on. So similarly, if I write x equals to, let's assume 12. So is the 12 less than any of this? No, sir. It will be false. So this is with respect to 6. This is no. So none of the tuple in the set of tuples satisfy the comparison condition. Therefore, any will return false. Come on, there should be at least one tuple that satisfies the comparison condition. So my question is, what happens? What happens if inner query result is empty? What will happen if inner query result is empty? So the idea is, if inner query result is empty, then any operator will always return false. Any operator will always return false. Okay, another important thing is, sir, if you are checking whether the element 5 is equals to any. So if I am saying 5 equals to any means 5 in this set. Sir, will there be any difference? Will there be any difference between equals to any and in? Will there be any difference between equals to any and in? No, sir. Equals to any and in are equivalent. Whenever in will return true, equals to any will also return true. Whenever in will return false, equals to any will also return false. Make sense? So these are two different types of operators. Now, we'll see the example in the upcoming sessions, not in the today's class, because first we need to cover all the concepts so that in the next class I'll be able to explain some examples. Right? So these are certain things. I'll give you two homework problems and I'll discuss those problems in the tomorrow's class. So it's not so that you will not get anything to do after this session. You will get 2 questions that you need to try by yourself, and then we'll discuss the solution of those questions in the next class. Chale, come on. So let's look at the all operator. So just like any, all will also be used along with other comparison operator. So just note down, just like any operator, all operator is also used along with other comparison operator. Same, sir. Okay, so when exactly all will return false, when exactly all will return false, that's what you need to understand. The objective of any is to search for a tuple. The objective of any is to search for a tuple for which the condition is true, right? But for all, the situation will be different. All will return false if there is any tuple. The moment one tuple is found for which the condition is false, all will say no, the condition is not true for all. So all will return false. So the idea is for all will return false if any tuple in the set of tuples fails the comparison condition. If any tuple in the set of tuples fails the comparison condition. So this is the most important thing. Important. This is important. Please. Important. All operator will return false if and only if at least one tuple in the set of tuples, obviously this is the output of inner query. From where do you get this inner set of tuples? So all operator will return false if and only if at least one tuple in the set of tuples fails the comparison condition. Can you please give us an example? Come on. Let's say if I say x, if I say greater than all, if I say x greater than all, and let's say assume the set of tuple is 1, 3, 4, 7, 9. 1, 3, 4, 7, 9. So what will be the output if x equals to 9? For x equals to 9, is 9 greater than all of them? Is 9 greater than all of them? Sir, when we compare with respect to 9, no sir. Yeah, yes sir. 9 is greater than 1, so it will not return false. It will check for the next one. 9 is greater than 3, so it will return true. Sir, 9 is greater than 4, so it will check for next tuple. 9 is greater than 7, so it will check for next tuple. But 9 is not greater than 9. 9 is not greater than 9. Therefore, all will return false with respect to because 9 is not greater than 9. So, for x equals to 9, all will return false. Similarly, if I take another example, let's assume if x equals to 3 for understanding, let's say x equals to 2. So, sir, 2. So, with respect to 2, it will be true. Now, 2 is not greater than 3. So, here itself, returns true with respect to false. Here, all will return true, will return false with respect to x equals to 9. I hope you understand. So, all will return false. So, if you take some value which is larger than all these values, let's assume if I take x equals to 15. So, 15 greater than 1. So, if we take with respect to 15, 1, right. No tuple failed the comparison condition. No tuple failed the comparison condition. Therefore, with respect to 15, all will return true. So, 15, all will return true. Why? Because no tuple failed the comparison condition. Because no tuple failed the comparison condition. Now my question is, what if the set of tuple is empty? What if set of tuple is empty? If this set itself is empty, if this set itself is empty, will there be any tuple to fail this comparison condition? If the set itself is empty, then will there be any tuple to fail the comparison condition? No, sir. If there is no tuple to fail the comparison condition, will all ever return false? No, sir. There is no one to fail the comparison condition. Therefore, for all will always return true. So, this is the difference between any and all. If inner query result is empty, any will always return true. If inner query result is empty, then any will always return true. And if inner query result, did I say something? If inner query result is empty, any will always return false. If inner query result is empty, then any will always return false because there is no tuple to satisfy the comparison condition. So it will return false. It is guaranteed to return false. But if inner query result is empty, then all will always return true because there is no one to fail the comparison condition. There is no one to fail the comparison condition. So what can we say? Note, if inner query result is empty, then all operator will always return true. Clear? Now, sir, we just said that we know what equals to any will be equivalent to n. Then what will be equivalent to not n? What will be equivalent to not n? So please, not n. Sir, you know when inner query result is empty, n will return false. When inner query result is empty, n will return false. So when inner query result is empty, not n should return true. That means not n must be with respect to for all. That means not n must be with respect to for all. Not n is equivalent to not equals to all. So for an element to not be present in the set, it should be not equals to all of them. It should be or it must be not equals to all of them. Yes or no? Something is not present in a set, it means that element is not equals to all the tuples of that set. Not equals to all the tuples or all the elements of that set. Clear? Okay, so the last operator that we need to discuss is the exist operator, and it is the easiest one. It is the easiest one. There is nothing to compare. The only concept is, if inner query result is not empty, then exist will return true. If inner query result is empty, then exist will return false. So exist will return true if and only if inner query result is not empty. What's the idea? Exist will return true if you use exist operator in a query, then exist will return true if and only if exist will return true if and only if inner query result is not empty. So it is if and only if. That means if inner query result is empty, it will return false. Not n is equivalent to not equals to, right? Okay, sir. What else? So that is, don't get confused. I don't want any confusion. If inner query result is not empty, if inner query result is empty, then exist will return false. As simple as that. No difference. Another. So just like other operators, we will have the complement of exist. So complement of exist is not exist. So whenever exist will return true, not exist will return false. Whenever exist will return false, not exist will return true. They will be complement of each other. So when exist is true, not exist will be false. When exist is false, not exist will be true. Now look at this example. So this is your homework problem. Let me redefine the problem for you. What output will be produced if given query is executed on the following relational instances? On the following relational instances. What are the instances? There's a table catalog, SID, PID, cost. So, S1 supplied P1 at 20 rupees, S1 supplied P2 at 30 rupees, S2 also supplied P2 at 25 rupees, S3 supplied P3 at 15 rupees. Whatever, it's not important. Another is the table parts, and I considered only two attributes with respect to parts table, that is PID and color. So what output will be produced by the given query if this query execute on this instances of relations? Yes, this is a correlated query, please. So that's the first thing that you need to identify. That's why I've given this as a homework problem, because first I need you to try this particular query. I have explained the order in which the query will execute. So in the tomorrow session, in the next session, I'll first give you the revision of this particular concept. Then I'll explain that how exactly this query will execute. So how do you identify that it is a correlated query? So there is a table catalog in the outer relation, and in the inner query, look at this. This is your inner query. In the inner query, it is using the attribute. It is the attribute from outer relation. So if inner query uses the attribute specified in the outer relation, then it is called correlated query. How will it execute? So the order of execution will be, for the first tuple, complete inner query will be executed. Based on that, we will check whether exists is true or false. Similarly, for the second tuple, the complete inner query will be executed. Based on that, we will check whether the exists is true or false. For the third tuple of the catalog table, we will execute the inner query, complete inner query. Then we will check whether the exists is true or false. So this will be done for each tuple of the outer relation. This will be done for the each tuple of the outer relation. Then we will decide that what output will be produced by this particular query. So that's one example. This is the question from the GATE. This is the question from the GATE exam, and in this particular question, it is using both independent as well as nested query in a single question. So you can actually check. What will happen? Sir, SQL queries. So there are relations: student, department, course, and register. There are relations: student, department, course, and register. What is actually happening? So here, select asterisk from student. So outer relation is student. Then it says where not exists. This is the complete inner query. But in this complete inner query, if you look at this, select course number from the course where department number is D01. So select, look at the query. Select course number from the table course where department number is D01. So this is an independent query. The query that select course number from course where department number is equals to D01 is independent query. Okay. Except is nothing but minus. Set difference. And look at this another query. So what will be produced? Select course number from register. Select course number from register. Where S number of the register table. Look. Sir, where the student number of the register table is the same as the student number from the attribute from outer relation. Therefore, I just wanted to explain. So what will happen? Sir, this specific information will be computed once. This particular information will be computed once. And for each tuple of outer relation, from the output of this, the output of this second correlated query will be subtracted, and based on that, we will check whether the exist returns true or false. Wonderful query. If you are able to understand that in what order it will execute, you understand the concept of independent subquery and correlated subquery. Make sense? So these are the two questions that I'll discuss in the tomorrow's class. This is one which is a GATE question, recent year question only. So don't think that it's too old. I believe it has been asked in 22 or 23 something. This is a GATE question from 22 or 23, not old enough. Okay. So anyway, so this is just a simple question to understand that how exactly the order will execute, or in what order the query or correlated query will execute. Clear? So yeah, 2022, whatever, I don't remember exactly, but that's fine. So this is an independent subquery, can be executed independently. The output produced by this will be nothing but, sir, there are only two courses from department 01, C11 and C12. Therefore, output of this query will be C11, C12. Output of this query will be C11 and C12. Whatever is produced by this particular query will be subtracted from C11 and C12. Very easy. Very easy. Very easy. Very easy. Thank you. Good name. Vinakota ji. Vinakota. Clear? So that's it. In tomorrow's session, we'll solve these two questions and then we will understand the concept of with clause. With is another beautiful concept that is available in the structured query language. It makes the query more understandable, more readable, right? So we'll understand that how exactly with clause will work along with other clauses of SQL and how exactly it will make the query writing more easy. Okay, so these are the three things that we have discussed. In the next class, we will solve those two questions and we will understand the concept of as a clause and with a clause. So after that, there will be two more lectures in which we will discuss the practice questions only. So one more thing that is left to discuss some other clauses and then we'll move to the practice questions. Good night. Good night. Please explain these two questions. Yeah, definitely. 100%. I'll not skip them. These are homework questions so that you guys can revise your notes and try to solve these two questions. And then we'll discuss this question so that it will be more understandable. Clear? So that will be all. Thank you very much. See you tomorrow with the, not tomorrow, maybe there will be a class on Monday. Tomorrow there will be no class. So we'll discuss it on Monday. Okay? Come on. Bye-bye.